Now, another thing we can do here is instead of manually entering the file signature as one of our identifiers, which is not always a bad idea, because for example, maybe we want to look at the JPEG file header instead, or the PDF, or the doc header. But there is a module that we can import into our YARA rules that will simplify the executable file check for us and also give us a ton of more functionality when it comes to creating conditions around executables, like looking at its different sectors or compiling its import hash and matching on that, and a lot more that's listed in the documentation. And so what I'll do here is just make a copy of our rule. So I'm just going to copy mimikatz.yar over to mimikatz2.yar, and then open this up in Sublime Text. And now what I can do is change up our rule a little bit. And so for our first line, I'm just going to run import the PE function or the module. And again, if I head back over to the documentation, I can go under modules here, and we can see already this PE module. And so this allows us, as you can see, to create more fine-grained rules around specifically portable executable files. And we can dig into different attributes of the file format as well. And so feel free to skim through this page if you want to figure out all the different attributes that we can identify in any of our executable files. Right? And so we can see things like the size of the image or the file alignment, base of data, base of code. I don't even know what that means, but we can start to pull out different attributes from any of these executable files. We can look at timestamps as well. Anyways, all we're doing now is just importing that actual module. Now we can start working with it, right? And so what I'm going to do is just comment out, our string here because we're not going to need it. And then what I can also do is change our first condition here. And so I'll leave in the and, but what I'll do is just take out that entire condition where we have the identifier of PE_signature. And instead, all we need to do is just call that module that we imported, right? And that's going to be PE. And now we can access the is_PE object. And that's just basically going to handle the check for us. And it will make sure that the file that we're detecting is in fact an executable file. And so now if I save this, head back to our terminal, just clear this out to clean it up, I can run YARA again, this time against Mimikatz, and make sure that I change our rule file here to, instead of mimikatz.yar, mimikatz2.yar. And we should get a match, nothing should change because we're still matching the portable executable. However, if I run the TAC-S here, well, we're only matching the URL this time because the condition here is kind of inferred. It's not something we're actually matching in a string. Cool. And to really drive this home one more time, I can run nano test.txt, just create a simple text file here and paste in that same URL. That URL that we're matching on in the actual, YARA rule itself. So I'll just save this. And so if I cat out test.txt, in theory, we are matching this URL, but it's not a portable executable, right? If I run file on test.txt, it's just going to be ASCII text. And so if I just run YARA again, this time on test.txt, we shouldn't get anything. Yeah, there we go. Nice. So I'll just delete test.txt. And so now, let's look at some real examples of YARA rules and use our understanding to try to make sense of them and decode them. And so I pulled a number of YARA rules from various GitHub repositories so we can take a look at them together. That's just going to be in this YARA rules file. And so you can see aside from our Mimikatz files, and let me just remove Mimikatz2, we don't really need that. However, we have a number of different ones that we can look at. And so first, I'm going to run Sublime Text to open up 00_webshell.yar. And from first glance, this rule looks pretty simple, right? And so we can start by looking at the meta section, right? And so we have a description, so it seems to be matching any web shells, specifically for the ice.php web shell. Under the author here, well, you can see that this is Florian Roth. We have the date of creation, the score of 70, and we also have a hash value, in this case it looks like an MD5 hash, that's likely associated with this ice.php file that it's designed to detect. And so the important thing here is going to be the string section, and we can see it's defining a very specific string. And so what we have here is the PHP syntax with this opening and closing PHP section. And within this, well, we don't need to be experts on PHP and understanding PHP code, but basically it's running the eval function that you can see here to essentially execute any commands or code that's listed out within these parentheses here. And when we look at what's being passed into the eval statement, well, it's going to be whatever the value is in the HTTP post parameter called ice. And so in theory, an attacker could navigate to this web shell and submit a post request to it with the ICE parameter equaling whoami. And the underlying web server would execute the whoami command and provide the results, essentially giving the attacker remote code execution. And we can see the full word modifier here, and this basically just makes sure that the match is only found if this entire string appears as a full word, instead of just a partial match or matching from any other string. And under the conditions here, well, we just have the very verbose all of them. And that just basically means any string that's defined here. In this case, we only have one. But if we had multiple identifiers here, like S1, S2, S3, well, this is just a very quick way of saying, match everything. And so that's pretty much it for this rule. It's not that complicated. It's just, it all basically comes down to this string here, in that it's identifying the specific well-known syntax of a PHP web shell. Cool. And so next, let's take a look at o1_PowerShell_empire.yar. Okay, so in this case, it looks like it's matching the PowerShell Empire script. Specifically, it's looking for the portscan.py file associated with the Empire framework, which is a PowerShell-based post-exploitation tool. And again, the author here is Florian Roth. We have a reference to the GitHub repository containing PowerShell Empire. And so in this case, our reference here is the actual tool itself that we're identifying. We have a date, a score, a hash, as well as a unique identifier. And so in this case, under our strings here, well, it looks like we're matching the invoke-portscan commandlet. And the second string here looks like it's matching, some specific output results. So we have selecting things here. We're selecting the host name. We have some open ports. And so this is how basically the script processes and outputs the portscan results. And so it's just another one of those ways in which we can detect specific strings within a script. However, where it gets interesting is under the conditions here. And so you can see first, we're matching a file size. And in this case, we're only matching files that are smaller than 14 kilobytes in size. And once again, we have all of them here to make sure we're matching both of these strings. And so again, with this one, pretty self-explanatory. It just comes down to identifying, what we're actually matching here. And the other interesting thing here is that we can use the file size function to make sure we're only matching files of a specific size, or greater than or less than a specific size. Cool. And so next, let's look at the stealbit rule file. In this case, it looks like we have some hexadecimal characters. However, I'm getting ahead of myself. Let's look at the meta tags. And so under description here, it looks like this rule is used to detect stealbit that's used by the Lockbit 2.0 ransomware gang. We can see that the author in this case is Frank Baldwin. We have a GitHub repository here, which appears to be another YAR file. We have a date, some hash values, and a unique identifier. And so again, we have a byte pattern here that's being searched for within the file. And interestingly, you can see we have some question marks here. And these question marks is a wildcard symbol, basically saying that, we want to match this specific byte value. And then anything here, this can be anything, or anything. And then we want to match 30, 81, and then again, anything here. And so these wildcard values, especially in these byte strings here, can be very powerful. And so I'm not sure what exactly this is matching, but based on the context here, it could be something like a decryption routine, or some sort of critical functionality in the way that the stealbit malware operates. And there might be some variations here, which is why we have to have some wildcards. And so under conditions, we have this uint16 with the 0 position that's equal to ox5a4d. And so this is another way for us to basically check if the file is an executable based on the magic number. And the reason why we kind of have it backwards here, instead of 4d5a, we have 5a4d, is because, well, I'm not an expert here, but it has to do with the little endian encoding. And so we're kind of getting it in reverse, but it doesn't really matter. The takeaway here is that we can also use this to match if a file is an executable by using the 0 position here and making sure that it's equal to this value. So again, we have another condition here to make sure the file size is less than 100 kilobytes. And of course, we're matching that C2 decryption pattern. Cool. And so lastly here, let's look at O3, the light FTP file. And based on the description here, it looks like it's detecting the light FTP server. And so, we have a bunch of meta information, but under the strings, it looks like we're looking for a full word here in wide character format, or UTF-16, and it's looking for some sort of seemingly configuration file, which is going to be ffTP.config. It also looks like we're getting some banner information from the actual binary itself, and so we can see 220 here, which is probably a status code for success. We can see light FTP server and the version number. We can see this specific string here. This might also be like a warning message or some sort of message that gets displayed to the user or some sort of logging or debugging information. We can see pass here. And so this is, pretty similar to standard FTP syntax. And again, we have 250 here, so another status code. And so you can see the different techniques here. So in this case, we're looking for specific banners or messages or debug information or logging information that gets displayed to the user or appears in some way within the binary. And again, under conditions here, we're using that uint16 with the 0 position, matching that executable file format, making sure it's less than 250 kilobytes. And interestingly, we can see 4 of them here. And so as sort of the name suggests here, we're going to match or detect if at least 4 of these strings have matched. And so we could have these 4, and maybe we didn't see this one in the file, that's fine, we'll still detect it. Or we could have, these bottom 4 here and still detect it. We have 5 strings defined, but we only need to match 4 of them. Any 4, doesn't matter. Nice. And so that was a neat look into some real-world YARA rules that are, used in the wild. And lastly here, I wanted to showcase the different ways that we can invoke YARA to scan things like an entire directory, or to scan things recursively. And I kind of mentioned this at the beginning of this lesson, but I want to showcase it as well. And so to scan an entire directory, it's pretty simple, right? And so right now I'm in the rules folder. And so what I can do is just run YARA, provide it that mimikatz.yar file, and back into the samples directory, and just leave it at that. I don't need to specify a specific file. I can just point to this directory, and it's going to look at every single file within this directory. And so if I just hit run, you can see, in this case, we're still only matching the Mimikatz file. But if we had multiple Mimikatz versions, or multiple copied binaries, well, we would start to match all of them as well. And to search for things recursively, well, I can just run this again, and I can provide the R flag here. And this R flag or option is really, really powerful because we can essentially turn YARA into a system scanning or a threat hunting tool to recursively look through the entire file system or sections of a file system to see everything that we can match. And again, we can also do this on Windows systems as well, and we could specify a directory or the system root to scan the entire file system. And when we do this, it does help to be in an administrator command prompt or be in a root terminal session so we don't run into a bunch of permission errors. And so anyways, what I can do here is point this to the /home/tcm directory, which is just my own user's home folder. And if I run this, it's going to recursively look through every single file and directory within my home folder and run this detection rule against every single file. And so this might take a second because, we're running through a bunch of files now. And pretty uneventful, we only had one match. But it did really look through every single file. And if there was another Mimikatz somewhere, in fact, let me demonstrate this actually. I'm going to copy, I'll go back and do samples under Mimikatz. And I'm just going to copy this basically anywhere. I'll go under downloads and just call it lol.exe. Now if I run this again, we should have 2 results this time. There we go, there's the original, and there is lol.exe. And so hopefully that kind of demonstrated things a little better. Now, like I said before, we absolutely just don't have the time to, cover every single possible way to write out identifiers and conditions. It's just not possible, right? To master YARA rule creation, it could take months or years. But my goal here was to get you up and running with YARA and to learn the fundamentals of how rule files are composed and how they can be ingested and understood, and how we can detect some basic patterns within malware. And so I hope you found this exploration into YARA rules super fascinating. Because I think YARA is a really, really powerful and useful tool in the SOC. And if you want to get more into malware analysis and writing malware reports and doing that, technical detection research, well, definitely get more hands-on practice with YARA rule writing and syntax. And don't forget the resources I provided in the phishing analysis section. You can get your hands on, any number of malware samples that you want and start writing detection rules based on, different things that you can find from static analysis. And I hate to say this, because I hate when people say this, but read through the documentation, and you can start to see all of the possible ways in which rules and conditions can be constructed. And so, I think what we should do next is to put our YARA rule writing and malware identification skills to some more practice and run through a quick challenge. And so I'll see you in the next lesson.